All right, folks, welcome to the April 3rd Thursday Web Forum. I'm Hillary Morris. I work on user support and communications for the South Atlantic and Southeast Blueprints. And as most of y'all probably know, we host this Web Forum on the third Thursday of every month at 10 a.m. And it's intended as an opportunity to share the latest updates on the Blueprint, get feedback and involvement from folks like you, and highlight exciting science in the world of landscape conservation in our region. So I'm going to ask that you all keep yourselves on mute throughout the presentation, please. I do have the power to mute everybody, but I'd rather not have to use it unless we get lots of background noise so that we can all interact a little bit more freely in the Q&A. And as a heads up, we are recording this web forum. I just do that as an option for the one or two people who inevitably wanted to attend but had a conflict. So I'll put the slides and the recording of the video from the calendar event on the South Atlantic LCC website within a couple of days. Any questions or comments before we get started? Our usual agenda. I'll start out by introducing our speaker. We'll hear from them for 30 to 40 minutes. We'll have plenty of time for Q&A and discussion at the end. And then I'll wrap up by previewing next month's webinar and giving some updates from your South Atlantic staff here in Raleigh. So with that, today we're going to be hearing from Steve Williams and Matt Rubino with the Basic Lab at NC State, and they're going to be talking about the second generation of GAP vertebrate species range and habitat maps. So with that, Steve and Matt, go ahead and share your screen and take it away.
Thank you, Hillary. And let me know when that comes up.
Yep, it's looking good.
All right, so as Hillary said, we're coming into the second generation of our data set, and that with continental data sets, I've seen this over and over with several different flavors of data out there. There's always a big push to get to the continental level, and sometimes you got to cut some corners to make that happen. But then the second generation, you start filling in some of those things that you missed or things that you want to improve upon, and that's what we're addressing here. Our initial data was on 2001 land cover, which is extremely dated at this point. So now we're moving on with 2016 land fire, which just recently came out, and so we'll talk more about that as we go through. So I'll talk about the modeling, how we're doing it. The improvements that we're making, both to the modeling, also to assessment, bringing in occurrence data for various aspects of the data, and also delivery as we set up and get that data out there. So the GAP objective, we have this mantra of keeping common species common. So we're looking at providing known range and habitat distribution data for all the terrestrial vertebrate species that we can do. And there's also fish coming online eventually, very soon actually, within the United States as measures of biodiversity. So we're looking at a large number of species across the continent. We want to keep the data as current as possible. Newer data input sources are becoming available. Again, the land cover from land fire, as well as species observations from all the citizen science data sets that are coming online recently. We want to improve the efficiencies of our data development, the documentation and delivery. Some of that we did very quickly on that first generation, so we want to go back and make sure that it is clear what we did, how we did it, and also the data that fed into it so that you can reconstruct it. So applications, when you have such a large data set spanning so many taxa, such a large extent, there's a wide way that you can start slicing and dicing. If you're looking at a particular community, you can grab those species associated with it and work with it. You can deal with different extents. But a lot of the work that we do is in conjunction with the PAD US data, the Protected Areas data set. And that can help assess conservation status, set conservation priorities. And of course, we have a wide range of users, land managers, researchers, policy advocates. So our modeling approach, we do a deductive model, basically expert opinion, that's based on habitat descriptions from primary literature and other compiled sources. And essentially, we're identifying the potential habitat that we derive from that the literature within a delineated known range. So it's a very simple approach, something that I think is very intuitive. If you're comfortable with what you're calling for the habitat of the species, if you're comfortable with the known range, then that is a potential habitat there. So it's the assumptions are very clear and straightforward on that. We delineate known range using a modified sub-watersheds out of the Huck 12 watershed data set. We had to modify it because a lot of the polygons along shorelines became problematic. They did very different things depending on where you were in the country with that. So we got these down to, 8,700 polygons across the country. So they're of a size that we're comfortable with. And because they're polygons, then we can attribute them with different aspects, different attributes. And we'll talk a little bit about that later as well. So the primary data that's running these models is basically the landfire existing vegetation type. And so they've come out with 856 map units, and they've done a much better job of pushing down into the wetland categories. And of course, landfire, their focus is on landfire. So the first generation of landfire really lumped a lot of wetlands together. And of course, that's key habitat for a lot of species. So they've done a much better job parsing that out, as well as bringing in a lot of ruderal types this time and parsing out other anthropogenic types. So we're much happier with the land cover, as well as they're stabilizing their legend, which gives us a lot of future room for what we're doing. So we don't have to constantly crosswalk our models to a new legend. We can focus on other things to improve. So other data layers that we use in particular models, if they're called for, include elevation, distance from water features, distance from forest and open ecotones, anthropogenic disturbance. There's one or two other ones, but essentially all these data layers are used as masks. So we take a known range, and then we say, okay, what is the map units in the known range that are appropriate for the species? And then we will apply several of these masks if we can pull that out of the literature. And essentially, you're paring down what you're lighting up on the landscape for that particular species. We don't get into habitat quality. We don't get into density of species. We are merely lighting up what we believe is appropriate habitat that that species will use during that season, either foraging or nesting or wintering. And it's in their that seasonal range. So we divide CONUS into 6 submodel extents. Part of that is processing initially when the first go around, but also because species will at times have different habitat selections throughout the CONUS essentially. So those 6 submodels give us some flexibility to change that model. We model in a raster environment with 30-meter square pixels, which is about 15 million pixels across the country. Or is it billion? I don't even know. It is a lot. So when you're looking continentally, it's very high detail, but don't go down to the 30-meter pixel and say that species is going to be in that square, because that is obviously overreaching what the accuracy is. So basically, you got to back up a little bit, you got to blur your eyes, and that is the habitat that we're talking about. So we're looking at 1,500, almost 1,600 species, and that comes out to about 5,500 individual models when we look at the region and the seasons that go into it, as well as some subspecies. We've got about 150, 160 subspecies that feed into it. So where we are sitting with this right now, we have our initial full species data set from the generation 1 of CONUS up on ScienceBase. That is the backbone of our data distribution. We've refactored several of the databases supporting the vertebrate species modeling into one. Essentially, over time, when we were doing that first generation, we were pushing what we knew, what we could do, and the process kind of spread out. So bringing that all down into one consolidated database was key. We also implemented some versioning protocol and infrastructure so that within a particular data error, say the 2001 error data, we can create a revision on the model and then post that up and track it so we're not losing what was done initially, so people know what particular version of the data they have, all that. So in the last year and a half, we developed the 2016 era ancillary data sets that support the vertebrate modeling. That includes a little bit of editing on the land cover, as well as all the other data types that you were seeing. And we've gone through and identified processing errors that we had in 2001 data. There were a few species that somehow in a copying process, it just clipped the data straight across the country. And obviously we want to fix those in the 2001 data set. And that's what we'll do initially to get our process down. But we probably aren't going to spend much time revising those 2001 models. We're going to move straight into 2016 and then move forward with what we want to see as corrections to the model or fine-tuning of the model there. So we have a revised modeling infrastructure and scripting environment set up. And we've gone through and reviewed all the taxonomic status of our species list. This is to keep up with what taxonomic changes are going on. Of course, taxonomy is like a shifting carpet, bleeding edge kind of thing, and we don't want to be right out in front of it, but we want to be up with, you know, the more major changes that have been accepted across the board. So that, you know, comes down to, I don't know, 20 changes that have happened since we developed our species list probably 10 years ago. So the next priorities as we move forward, we need to implement those taxonomic edits through our data set. And then we rebuild the species habitat relationships using that crosswalk from 2001 land cover to the 2016. That's what I've been doing for the last month or two, is getting that process set up. We're about ready to fire that off as soon as we get those taxonomic edits incorporated. Come up with our priority list of how we're going to model, the order of model for species, and we prioritize any partnerships and co-analyses that we have going on, and we're also looking at doing quarterly updates of these models as opposed to waiting until we have the full data set and then putting one update up. That way we're getting the data out there sooner. So we also want to incorporate species occurrence data into the known range polygons. That is something that we left behind when we left state projects. As we scale up, the order of magnitude of work involved just kept getting higher and higher. So we had to drop dealing with occurrence data to inform our known ranges, both in the regional projects, but also in that first generation of the CONUS data. Now that a lot of occurrence data is readily accessible online, we've gone back into that, and we'll talk a little bit about how we're dealing with that volume of data and how to filter it. But one of the uses is we're going to confirm our known range polygons as well as do an assessment of our models that Matt will talk about. And then, of course, we want to run, review, and mosaic those submodels together. And then create, review, and post all those digital products that we have. So timeline, and again, that's what we're called in to talk about. So I'm sure this hopefully we won't lose people watching the show here. But essentially, we're looking at quarterly releases of the completed data. We envision that first release being in the summer, this summer. And then we're hoping to get everything done within a year's time. And so now Matt will talk about how we're, again, using occurrence data records to bring them into the species data sets. And I guess I will just advance the slide when he says beep.
Perfect.
Okay, thanks, Steve. So yeah, I'm going to talk about incorporating how we're incorporating some of these species occurrences into our foundational products and product development using widely available data repositories such as GBIF or Bison or eBird. Let's see, I've lost the slideshow. Steve?
Did we lose Steve? Perhaps we did. I have a copy of his slideshow, so let me just bring that up.
Okay.
Do you have a copy of the slides, Matt? Or
I do not. Oh, Steve?
Steve, did we get you back?
You're muted.
I tried to mute and evidently I left.
No worries.
So now I'm back and I'm looking for my slide to share again.
Yeah, if you're used to Zoom, Teams can be a little bit of a learning curve. No worries.
All right.
Okay, just go to the next slide. Okay, so currently what we're using some of these occurrence records for is, like Steve talked about, dealing with our ranges and maybe altering our range delineations. And we're also using them to assess the models and the maps that we've done for 2001, and then eventually we'll use for our 2016 models. But ultimately, our goal is to develop a workflow that's open and adheres to USGS standards of transparency, efficiency, repeatability, and a process that's iterable and readily accessible. Next slide. Okay. So to this end, Nathan Tarr, and I think he gave a talk on this forum actually about a year ago, maybe a year and a half ago. Mm-hmm. But he developed a framework that he dubbed the Wildlife Wrangler, which is basically a combination of open source code and SQL databases to access occurrence records, filter them, and store them in an open and transferable way. It has undergone quite an extensive rewrite. We were talking about this yesterday, actually, but it is all available on his GitHub page if you want to take a look at it with that URL. And it is currently undergoing a review in USGS, a software review, so that it prior to its kind of official release on USGS Science Base. Next slide. So in essence, it's a series of Python and some code in R to access occurrence APIs such as GBIF, to filter and store the occurrence records in a SQLite database where the workflow of all that processing of grabbing the data, which species, how you filter the data based on various parameters of those occurrence records, and it's all documented in a Jupyter notebook so that anybody can go back and look and see how a given user accessed all that data and what the final result was, and use it, and how you use it ultimately in whatever project you're using it for, like delineating range map for a given species. Next slide. So it's currently being, like I said, currently being reviewed at USGS prior to release on Sciencebase, on the Sciencebase repository. And it's undergoing extensive revisions. So he's actually streamlining a lot of the code that's used to pull down all that data and filter it. But again, all the software is open source. It's not using any kind of proprietary software like Esri or Microsoft. So everything's open, and he's currently working to make it much more efficient at handling large data requests, like tens of millions of records at once, which can be very cumbersome. And he's also working to have it incorporate eBird, which is the premier data set of bird records, which currently does not have an API, but if you make a data request, they actually will send you all the records for a given time period, and he's kind of trying to work that into the workflow so that it works similarly to accessing APIs. Next slide. So next I'm going to talk about how we utilize some of these occurrence records and that wildlife wrangler to actually assess our habitat maps. And so this would be for the habitat maps from 2001. And again, we're gonna hopefully use the same workflow when we do our 2016 models. Next slide. So in the past, GAP models and maps, we've really not have any kind of quantitative methods for assessing our maps. A lot of times what we had was, especially with the 2001, we had a kind of an internal qualitative review, but we didn't have anything quantitative. So what we wanted to do was take advantage of these, these large data repositories like GBIF and Bison, so that we could use them to evaluate our maps and hopefully provide, end users some quantitative validation for our models, and then something internally that we could use to maybe alter models or help refine the parameters that go into our habitat affinities, like Steve was talking about. But part of the problem is what kind of metrics can we really develop, given that the vast majority of these data are really only presence-only data. And they also have varying degrees of locational uncertainty. So like if the figure on the right shows an example of a salamander species that we modeled in the Appalachians, the Southern Appalachians. The gray is the range we've delineated. And the zoom in, you can see that the green pixels are predicted habitat. The red dots are occurrence locations, and then those buffers around the occurrences are the locational uncertainty that was provided in this case in GBIF. We use GBIF. That locational uncertainty, so a buffer on the locational, the coordinates of those given locations. And of course, we're trying to assess our maps at 30-meter resolution with a combination of presence only and locational uncertainty. Next slide. So the methods we came up with there was a couple of things we did, but basically we wanted to, the best thing we could do was basically assess these maps relative to random. So this is something that was similar to an approach that Rondinini et al. Took in 2011, where they modeled mammal species throughout the world, and they did what they called point prevalence versus model prevalence. And so this is an assessment relative to random. So what we did was we came up with a method we call buffer proportion assessment, where it's comparing the mean proportion of habitat adjacent to those occurrence locations to the proportion of habitat throughout the entire range. Okay, so the models that would basically be about random would have about the same proportion of habitat adjacent to those occurrences as those throughout the range. So if we're doing a better job at predicting habitat close to those locations, you're going to be somewhere above that 1-1 line. So those are going to be models that are better than random. Anything below that is going to be, we're going to be considering worse than random. Next slide. So the other thing we can do is we can measure sensitivity at varying buffer distances. So sensitivity, which is just the true positive fraction. So it's the true positives divided by the true positives plus the false negatives, where true positive is measured where at least one habitat cell occurs within that point location buffer. And a false negative would be where there are no habitat cells within occurrence location buffer. So on the right-hand side, the figure shows an example for the green salamander, where basically you see as the buffer distances increase, the sensitivity increases, right? So it kind of makes sense that the more points that you have that you can assess, the better the model assesses. So in this case, you can see that right around the 500 to 1,000 meter distance from is about where the scale at which your model becomes a little bit more useful, as it were. And for each one of these distance categories, we can actually do a statistical significance test using a one-sided binomial. So this is an example for just one species. Next slide. So to date, we have done assessment for all the amphibians that we modeled in 2001. These are just some summaries of what we found. There were about 284 taxa that we modeled for 2001 amphibians. For a little over 70, we didn't have enough data from GBIF to be able to assess those models. So we evaluated 213 taxa. And on the left is that buffer proportion assessment metric, where you can see basically the majority of those species were assessed as better than random. So most of those dots are above the 1-1 line. So each one of those circles is a species that was evaluated, and the size of the circles is related to the number of records that were used to assess that model. And on the right is the sensitivity that across all the species as at varying buffer distances of those 7 categories of buffer distances. And again, you can see as the buffer distance increases, the sensitivity increases. Basically, you're kind of saying that the model assesses better at broader scales. So maybe at 1,000 meters is, like Steve was saying, you don't want to assess an individual pixel, whether it's suitable or unsuitable. You really want to take a broader look, and this is kind of verifying that information there. That maybe at 1,000 meters or 1,500 meters is really where at the scale you should probably be utilizing these data at. Next slide. So some of our next steps, well, we've got 2 USGS publications coming out. One is a techniques and methods that outlines all our methodology, and then a scientific investigations report, particularly for the amphibians. We're going to summarize all the analyses we did on the assessment for amphibians. And of course, all this is open source code that we want to get reviewed and published so that anybody can use our methodologies. And we're going to use these to prioritize any of the poorly performing models that we had in 2001 and going forward to 2016, so we can take a look at things like taxonomy. Do we need to access other occurrence data sources? Like I said, we use just GBIF for the amphibians. We may need to dig into other data sources, especially for the species we couldn't evaluate. And then do we need to update the ranges? And then take a look at the habitat affinities. Is there something about the poorly performing models that we need to change in terms of the habitat affinities? And of course, we're in the process of evaluating the 3 other remaining taxa: the birds, the mammals, the reptiles, and those will go into similar scientific investigation reports once we have those done. And that's all I got.
All right, I'm successfully navigating the hang up button and the microphone button, so that's all good news. I can learn even at this age. So the digital products that we're going to be pushing out once we finish things up. So I was saying earlier, the backbone of that distribution is the science-based items, and these are on ScienceBase. I'm feeling that most people are familiar with that. It's a vetted repository. We've got all habitat maps and range maps up there. So there's 4,000 data layers that we have sitting up in there, including the 4 taxa richness maps that we had put together for an earlier analysis publication, and the analytic database, which is basically the backbone that we use for a lot of our analyses. So we don't have to delve down into spatial operations that take time. We've basically pre-compiled on polygon data sets that are the most common ones, state, county, LCC, ecoregions, as well as PAD, for each of the species and the land cover. And then we can basically run table operations, which are a lot quicker, and get that data out there. So all those are online right now. Then we went and put together a very basic species viewer with Terria map. Again, a vetted USGS platform. Basically, we make a configuration file that has all of our vertebrate data in it, and then we apply it to this map service. So then they can be lit up. You can pan around. You can turn things on and off. Opacity, transparency, and you can draw multiple species. Although that does get problematic at some level. But this is a very basic viewer. And we're not going to be able to push it in directions that we would like to. So, it's just a quick viewer. And then right now what we have is a tabular download off of our webpage for all the species. You can get the habitat reports, the range data, habitat data, as well as a link into the species viewer. But this is a single-click operation, so this is not ideal for bringing down large amounts of data, and that's something that we're working on right now. And that segues right into the next priority. So basically, data products can be summarized on delivery, a focused analysis, something that we do in-house or with a partner, and that we can apply. And then online tools, which are more of an open approach for the end user, not having to download data onto their own GIS system, but to basically use an online GIS to get at whatever question they want to apply to it. Although there are sideboards on that as well, but not nearly as much as focused analyses. So again, we want to develop a multiple efficient species online data delivery system, both tabular and spatial extent capabilities, how you select the species, and then basically a zip process that then notifies you when that can be downloaded, or actually it's sent, or the file is ready, or what have you. We're currently talking about doing that, and hopefully we can get that up and running within 6 months. We want to generate and publish multiple richness data sets down to habitat guilds, say longleaf, associated species, have a richness map of that, and then publish these because we feel like these could be used in both the focus analyses as well as just being data downloads that people could use. We want to develop, again, focused analyses built through the analytic database and Tableau, which is another USGS vetted platform that then can push things out quickly into publications and also be incorporated into online content. And the final end goal, the complicated end goal, is get that online tool set that integrates both the land cover, PAD-US, terrestrial vertebrate species, as well as the aquatic gap data for species, as well as their threats data layers and such, into a visual and quantifiable, online GIS. And this is something that we had done initially on the state level with actually an ArcView installation, proprietary software, and then we moved to an online tool with the help of Doug Newcomb, which we found to be very useful. But then, when you step up, 6 times the extent and data, that becomes problematic. That and the Wild West days of online tools is over. What with security issues and all that. So we have to be careful about how we put the data out there, the exposure of the systems that they sit on. So all this is now going through USGS as opposed to something that we would do in-house at NC State, where we didn't have proper parental oversight. Essentially, is how I would categorize that. So we are talking about doing that, and I look forward to getting that out there, because that's something I find exciting to talk about and get data into the hands of people that can use it. So thanks, and we can take any questions. I guess one question that I have is basically, how do you guys anticipate using the data, and how would you like to receive it? I think you guys are probably on the higher end of data users, so I have an inclination of what you would want, but it would be good to hear that, because we don't get enough feedback. Essentially, so a lot of times we're working in the dark, and certainly over the last 2 years or so, we've had our head very much down trying to process things through and get them to a state that we can start putting it out. But we're coming to that point where we're ready to start showing the data and start talking about it again, and doing that outreach that's so critical to get data used. So thank you.
Awesome, thanks, Steve. I see that Doug Newcomb, you have your hand up. Do you want to kick us off with the Q&A? You can just unmute yourself if you want.
Sure. I've got a couple of questions off the top of the head, and first off, the SQLite database that Nathan's using, has he considered using GeoPackage format for that, which is basically an SQLite database with the spatial enhancements? Or is there any reason why he didn't go that route?
He has actually migrated away from SQLite, and we just didn't update the graphic on that. That's one of the streamlining that he has done. He may be using what you referenced. I did not retain that detail, but I do know that he's moved away from SQLite.
Well, no, I think he was talking about Spatial Light, which was a product that that was developed at in Italy or something like that, and actually I think he's moving away from just using it in a spatial way, and mostly the SQLite database is used just to store the occurrence records.
Okay.
There's not a whole lot of spatial functionality in the Wrangler right now. I think he was trying to do something where you could basically give use a polygon to clip occurrence records, but I think he's moving away from that. But the SQLite database is just mostly to store the occurrence locations, and then all the filtering mechanisms that were used to that an end user would use to pull down data.
Okay, I would like to talk to Nathan further about the whole records wrangler process. That can be a different conversation. The second question I had is, you mentioned you were interested in knowing how we would access the data. I'm wondering if you're looking at setting up a web processing service an OGC standard web processing service in the back end so that people could submit queries and have the results returned to them as a spatial data layer to their desktops.
Yeah, we're open to that. That's on the, the more complex end of the spectrum.
Yeah.
So we're really focused on the simple things. We need a viewer. If we can't view the data, we're in trouble. So we need a viewer. We need to download the data. We need efficient ways to download the data.
Mm-hmm.
And then we're stepping up that complexity as we go forward. So certainly we're looking at that. It'd be nice to have clip and zip, where it's doing that process and given the extent that people are interested in, instead of these CONUS extents that they may or may not be interested in and clogging up the bandwidth.
Okay, that's fair. Trying to think. I could talk to you more about other stuff offline, Steve. I'll let other people hop in.
Thanks. Good questions, Doug. Anybody else have a question for Steve or Matt, or feedback on how they would use the updated GAP data or how they'd like to interact with that data?
Hey, Steve, it's Amy Keister. So yeah, to answer your question, we have historically downloaded the data and then kind of did our own, working with it on our own desktop GIS. And so your work to make the downloads easy and a clip and zip, I think, would be really helpful for me. As I learn and grow, I might be able to take advantage of some of the stuff that Doug is talking about, where I submit queries to you and do that kind of stuff. But so far, I've been old school and just have been downloading and working with it on my own desktop GIS. So.
Yeah, and Amy, since you're a special friend that goes way back, we can certainly take a hard drive and load everything up for you.
Right.
The benefit of doing that is that not just give you the data sets, which are basically stripped down with null data and as minimal extent as possible, which then you have to basically build up with zeros so everyone has the same extent spatially so that you can then combine it. We've done that. And so there's, a whole lot more to the data if we hand it over that way.
Right. Yeah, that's I hadn't even thought about that.
Yeah, and it'll come both as with seasonal, zeros, ones for season, as well as altogether, as well as the raw data that has different codes for the season with null and all that. So it just gets you down the road much further to start tying the data together when you start looking at richness and whatnot.
Excellent. Yeah, that would be great.
You have plenty of time for more questions, folks, if anybody else wants to jump in or provide feedback.
This is Wayne Thogmartin. I have a question about the species occurrence information and how it's used. Specifically, I'm interested in understanding how extraliminal observations of species are addressed because if you include these extraliminal observations, you basically are biasing the performance of your models is going to degrade if you include those observations. And so I'm just wondering if there's a way to, exclude them?
Yeah. For one thing, I don't know if you noticed that graphic that we had showing the range and the data points prior to to talk about the wildlife wrangler. But one of the things we might want to incorporate is those kind of outside what we determine to be the range. If those are appropriate, that maybe need to go into our range. So from the range delineation standpoint, we'd have to do some vetting on those data points, those occurrences, to see if they're, if we need to incorporate those in our range. But in terms of the model assessments, those are going into our model assessments. So they're at least for the amphibians that we've done thus far. But so, if they're outside of what we consider the delineated range, obviously we're not going to predict any habitat out there. So those are going to bias our models and our maps in a negative way. What we're trying to do is trying to filter out a lot of that data. So that was the Wrangler is using a standard methodology to filter out some of those data that we think are not appropriate, and hopefully doing it all in an open way so that if anybody wants to go back and look at those data, like, oh, you threw out all these records over here, was that appropriate, that kind of thing. So it's kind of a mixed bag, in terms of what you want to include and what you don't want to include. Does that answer your question?
Yeah, I mean, it helps. I mean, in a dynamic world, obviously, species are testing the limits of their range, and under climate change, we expect those ranges to shift. And how you determine what is the current range versus just sort of species testing that boundary, that limit to their range, is an interesting question, and I don't know how to address it in the context of your work, but I'm hoping to learn from what you guys do.
Yeah, and I would also add, especially with birds, some very mobile species and ones that can be migrating, and trying to set the parameters of, okay, this is the season that we're interested in, and all of that is just a shifting sand right now, and we have to be very careful about how we do that. And that was again another impetus to make sure that we are documenting exactly what points we're using and how we filtered it, to try and back that up as far as what points that we're including.
We also have a question in the chat. Have you done any comparing of your range maps with those from the Fish and Wildlife Service, IPAC, or Ecosystem, or any others?
No, not really. Actually, you'd have to talk to Nathan about that, because he's been working with that Wrangler code to, how to incorporate that into ranges, and I'm not sure if he's done any comparisons to other sources of range delineations.
Okay, thanks. We have just a comment from Scott in the chat, just saying that this is great work, and he'll be reflecting on how to use those in his work. Any other questions or feedback for Steve or Matt?
Great job. Look forward to the data.
Thanks. Yeah. There'll be a lot of enthusiasm for using this data from a lot of folks on the line. I'll pause one more time for questions. All right, well, I'm going to go ahead and take back sharing here real quick and just wrap up with some slides and updates from our team. Are you all seeing my screen?
Yes.
Okay, great. Yep. I always like to check. So next month's webinar, looks like I've neglected to change the date on this slide. It's going to be May 20th of next month. So Rua is going to be given a presentation on Zonation, which is the modeling software program that's used to create the South Atlantic Conservation Blueprint. It basically prioritizes areas of the South Atlantic based on how important they are for a suite of terrestrial, freshwater, and marine indicators. And we usually don't talk a whole lot about the nitty-gritty of how zonation works, so this will just be an opportunity to dive a little bit more deeply into the details, how the algorithm prioritizes, how we weight different indicators within zonation, and more. And this is particularly interesting because in 2022, we're going to start using zonation to prioritize a larger swath of the Southeast, not just the South Atlantic geography, but we're going to extend many of the South Atlantic blueprint indicators and methods across a larger area with the goal of creating a more consistent Southeast blueprint. And so this new expanded zonation methodology is going to cover 12 states of the Southeast next year. We'll be continuing to draw on data and best practices and lessons learned from neighboring plans like Appalachian Naturescape and the Middle Southeast Blueprint. So this webinar will just be a great opportunity to learn and ask questions, not just about how the South Atlantic Blueprint works, but how this larger input to the Southeast Blueprint is going to work starting in 2022. So I definitely encourage you to check out that webinar. And then I wanted to provide just a brief staff update from our team here in Raleigh that the draft South Atlantic Blueprint update for this year is coming soon. We have already wrapped up indicator improvements to a whole bunch of different indicators that will be used in this year's blueprint. Some noteworthy ones are big improvements in the marine and the estuarine environments. We've improved some of our aquatic indicators to be more consistent with SARP and the Atlantic Coast Fish Habitat Partnership. We've completely overhauled our regularly burned habitat indicator and have some amazing new data on prescribed fire that we're incorporating. So lots of great improvements to the indicators this year. RUA's already started running zonation runs. We'll be continuing to use the same improved modeling process from last year where we're running zonation within subregions. And then late May, early June, we're looking to have virtual workshops to review Draft Blueprint 2021. We'll probably be using a similar approach to last year where we're using Mural to kind of interact around big virtual maps and provide feedback on where the blueprint looks good, where it might need some tweaks. And then we'll have our final release scheduled for August of this year. And then moving into next year, like I said, we'll be kind of expanding these indicators and these approaches to a larger 12-state area beyond just the South Atlantic. So just wanted to preview that the next South Atlantic blueprint is coming soon. And I always like to end on this slide about how to get more involved in the blueprint. I encourage you to join the South Atlantic web community at southatlanticlcc.org. That will get you signed up for a monthly newsletter about the South Atlantic Blueprint and a reminder email about this web forum. And then you can always connect with your blueprint staff in Raleigh. That's me and Amy and Rua and Mallory and Louise, or other members of your cooperative. And of course, we encourage you to explore the Conservation Blueprint online and let us know how it's working, and reach out if you need any help using it in your work. So with that, I'm going to pause again for questions, either for me or for Steve or Matt. Well, thanks everybody for tuning in. Really appreciate that awesome presentation, Steve and Matt. That was fabulous. And hopefully you guys got some good feedback that'll be helpful for you too as you move forward with this update. I hope that we will see you all in May.
All right. Thank you.
Hey, thanks.
Bye, everybody.